In this video we shall discuss such fundamental concept of relational databases as relations. So by definition, a relation is a set of entity occurrences that have the same attributes together with these attributes. Let's look at an example. Imagine we have some relation describing user that has an ID and name. Of course, we may have several users. For instance, user 1, user 2, and so on. All those users are occurrences, but they have the same attributes. So this is the relation. And let's review this in more details. Imagine we have some relation describing an employee. The whole picture here is the relation, but it has some details. It has columns, also known as attributes or table fields, and it has rows, also known as tuples or table records. The number of table fields is arity. The number of table rows is power. All the data itself is table body. The description of attributes is table head. Each attribute has a name, a data type, and some other properties, like is it nullable or not, is it primary key or not, and so on. As it was mentioned a couple of seconds ago, each attribute has a data type, like integer, string, and so on. But there may be another constraint called domain. Because, for instance, let's compare this string and this string. Of course, they are both strings, but employee name and phone number has different formats, different possible values, and so on, and all these are described by data domain. To understand and memorize these definitions better, please pause the video and read the definitions of data type, attribute domain, attribute, and tuple. There are several terms that should be demystified, because they may be confusing for the beginners. So, what is a relation schema? It's really just a schema, a description created with some modeling tool. Relation variable or RealVar is a real database table that was created with that schema. Relation or relation value is a data that's stored inside a table that was described by that schema. And the final one, the derived RealVar or view, is literally a named SQL query, so it's another approach of accessing data that's stored in that real table described by that schema. And there are more definitions needed to be explained. We'll review them from different point of view, from the point of view of subject matter, relational theory, database, and physical storage. The first group describes something like entity, relation, table, file, and all those terms are synonyms. They only depending on the point of view. The second group is a group of synonyms too. The instance, the tuple, the row, the record are synonyms, just depending on the point of view. And the third group is a group of synonyms too. A property, an attribute, a column, a field are synonyms, also depending on the point of view. So, until you are writing a scientific article, you may use such group of terms as synonyms. Nothing bad comes from it. How can we create a relation? There are two basic ways. The first is to use SQL. We can tell a database to create a table with a specified name, with several of attributes, with certain data types and some other properties. We may enforce a constraint like primary key, telling that this attribute is the primary key. And the second approach is using some special tool. We'll use such tool as Spark's Enterprise Architect. So once you've started Sparx Enterprise Architect and created a new project, we have to perform some actions. First, we need to create a model using Wizard. Let's do it. Let's select Database Engineering here in the menu and scroll down for basic MySQL model. Then we have to click Create Patterns. Here it is, all set. Here we see conceptual level, logical level, physical level. It's not important for our purpose which level shall we work with. We only have to eliminate those stub objects. So let's delete them all. Then we may double click any level we want. Let's proceed with physical level. Right click, select Show Toolbox. Here it is. Select Table, click here. A new table was created. Now right click, Properties, and we shall name the table. Okay, let's name it User. In real life, we also have to fill in the comment, but for the sake of time saving, we shall not do it right now. Clicking OK, another right click, Features, Columns, and we shall insert several columns. For instance, ID and name. Of course, in real life, we also have to fill in the comments here. Let's select data types. The ID should be integer, name should be string, variable char set with a length of 200 maximum. The ID will be the primary key, auto-incremented, unsigned in order to double the available range of values. And that's almost all. Clicking close. Here's the result. Now we shall export this table into a real database in real DBMS. We may select Develop here, Database Builder. If you see those dummy stub tables, that means that we've forgotten something here. That doesn't matter right now. We may select the root element, right click, generate DDL, data definition language, clicking, uncheck anything unneeded, just leave our user table, check, select a file, okay, let it be database A, save, and click generate. All done, we may close this window. We may use any text editor. I am using Notepad++ now to review the result. Here is the SQL code that was automatically generated by Sparx Enterprise Architect. Then I am switching to MySQL Workbench to work with MySQL. And let's start with creating new database. Let's name it, for instance, DBA. Select the char set like UTF-8, General CI, click Apply. We may review the SQL code if needed. Click Apply once again. All done. Click Finish. Here is the database A. We may right-click and set it as default schema. Then we open New SQL window, switch to our text editor, select all, copy, paste, and execute the script. And here we see in the log that everything is fine. We may click Refresh and check if our table was created for real. Here it is. And that's how you may create any number of relations or tables. And of course, we shall continue reviewing relations, their attributes, and so on in the next videos.